Here we are on page 21. We're going to get the basics of right triangles before jumping into trigonometry. Let's make sure we get this. Fill in the missing values of the Pythagorean triples. That means we're doing a squared plus b squared equals c squared. And this has to do with, yes, a right triangle of A, B, C with the hypotenuse there. So in this one we are going to have 3 squared plus 4 squared equals c squared. We can do this one. That's 9 plus 16 is 25 equals c squared. So c would be a plus or minus 5, but negative 5 doesn't make any sense for the length of a hypotenuse. So c is going to be 5. On the next one, this is 5 squared plus b squared equals 13 squared. So we get 25 plus b squared equals 169. Subtract 25 and we get b squared equals 144. So b is going to be 12. Yeah, there's a 12 right there. Good. On the next one, we have 12 squared plus b squared equals 20 squared. So 144 plus b squared equals 400. Subtract that and we get b squared equals 256. We know what that is. B squared equals 256. B is going to be a 16. So 12, 16, 20. Notice that that's just multiplying a 3, 4, 5 by 4s. These Pythagorean triples are pretty important in the fact that they are a set of natural numbers that actually fit into this equation. And so that's good to know and to keep in mind, and we'll see them pop up all over the place. Okay, on the next one we have a squared plus 15 squared equals 17 squared. So we get, subtract 15 squared from both sides, we get a squared. Let's see what that is. That's 225, and 17 squared is 289. So a squared, if we subtract those, is 64. Oh, good. That's nice. A equals 8. So 8, 15, 17 is that one. And the next one is 724 blank. So we get 7 squared plus 24 squared equals c squared. It's 49 plus, this is 576. I believe that's correct, equals c squared. C squared equals 625. Oh, hey, we know that one. C is 25. Now we see why it was so valuable to learn the squares up to and including 20 and 25 and some of those others. So this is a 25. All right, 6 blank 34. Hey, look at that, 16. It's going to be double this one right here. We have a 16 and a 34. It's got to be a 30, but let's double check that and not jump completely to conclusions. So 16 squared plus b squared equals 34 squared. Let's take out that calculator. I'm going to need some of those. We know this one's 256, but what is 34 squared? 1156. So we get 256 plus b squared equals 1156. Subtract 256 and we get b squared equals 900. Yep, b is going to be a 30. So yep, 30 right there. That's great. Okay, these last two look like they're a bit bigger numbers. Let's see if we can do it. We have a squared plus 60 squared. A squared plus 60 squared equals 61 squared. Let's plug those in the calculator. I don't know what those are exactly. 60 squared is 3600. Knew that one. 61 squared is 3721. So we had a squared plus 3600 equals 3721. Subtract 3600 from both sides and we get a squared equals 121. A then is 11. Oh, that's good to know. That's good to know. Okay, and the last one. This is 21b and 221. So we get 21 squared plus b squared equals 221 squared. Wow. Okay, so 21 squared is, let's make sure we get that one right, 441. 441 plus b squared equals, and 221 squared 221 squared, 48841. 48841. B squared then equals, if we subtract 441, it's going to be 48400. So we subtract 441, we get 48400, and now we're going to square root that number, and we get 220. Wow, that actually came out to be equal. Good, so there's a 220 there. Now there's something that you should note about especially these bigger ones, but even down lower. When you can add these two consecutive numbers together, an even and an odd number together, you add them to a perfect square. So these two added up to 441. You'll notice it's the square of that one. 60 plus 61 was 121. 24 and 25 were 49. So you can actually find a Pythagorean triple that has any odd number you want. So as a side note, if you wanted to see the number 19 be part of a Pythagorean triple, you square this and you get 361. And all you've got to do is find the two consecutive integers that add up to 361, which is 180 and 181. And yes, because the difference between these two squares is 180 plus 181, 361, that would be a Pythagorean triple as well. Kind of an interesting number theory connection there. Good.